welcome to this first look demo of Cisco Secure Access, an all-new security service edge offering from Cisco Security. Cisco Secure Access has been built to seamlessly connect your users to everything they need to do their job, without worrying about the nuance of how to connect. It does all of this while keeping the administrator experience easy to manage. Let's start with the end user experience first. Our goal here is to ensure our user has access to everything they need without needing to think about connectivity. Our user here has just logged into their endpoint, and it's time for them to get to work. Starting with the simple infrastructure management application, they can just click on the web bookmark and are brought right into the app. They can also navigate to their product agile board in Jira just as easily. You can see that here. Now, as an engineer, they also need access to some additional non-web-based applications. In this scenario, our user needs to connect to an app database to make some changes. However, that access has not been permitted yet. So we can see when the user tries to connect to that database, the connection fails. Now, let's go ahead and see how easy it is to enable that access. Taking a peek at the admin experience for Cisco Secure Access, let's go through how an administrator can easily grant secure access to an application for their users. In this case, for our engineers, they need access to the system database. To enable this, let's first navigate to our access policy page and take a look at the existing rules. The Cisco Secure Access policy is unique in that it's unified. This means that the private and internet access rules live in the same converged policy set. This results in a far simpler and easier to manage policy. It means you're not required to jump back and forth between different policies or even dashboards when managing or configuring more complex rule sets. Taking a look here at our policy, we can see that our engineers have access to a specific private resource group. The policy in Secure Access is intent-based. So what this means is all one needs to think about when writing a rule is what they desire. Who is either allowed or not allowed to access what? In this case, the who, or source, is an Active Directory engineering group. And the what, or destination, is a custom-defined group of resources that the engineers require to work. In order to grant our engineer access to the database, we simply need to add the database application to the resource group being used in the rule. We can easily navigate to the private resources and our resource groups tab. Here, we select the group from our policy and now add our PostgreSDB resource into it. This resource definition contains all of the relevant details about our database. The address or FQDN it's reachable by, the port, the protocol, and even the type of connectivity for the application, VPN, ZTNA, or even both. And all we need to do is drop it into our resource group. With our application added into the group, let's go back to our user and have them reconnect to the database. Here, our user will now run the same action to connect. Here, our user will now run the same action to connect. In a moment, there it is, it's connected. The user can now navigate the database, see statistics, and continue to work. Now, our user didn't need to do anything special. There was no reconnect, no wait for client sync, it just worked. This is all made possible through our unified secure client. You can see it has a modular design. And what that means is that this client, in conjunction with the Secure Access policy configuration, can take care of deciding the underlying connectivity without burdening the user. That means our user just has transparent access. They open up the laptop and get to work. With our user up and running, let's go ahead and go through the process of setting up an entirely new application and defining policy to enable access. There are three core components to ensuring secure access for our users. The first is connecting our infrastructure. The second is provisioning our users and authentication. and finally, defining the applications and security policy. So with that, let's start with connectivity and connecting our infrastructure into Cisco Secure Access. If we select Network Tunnels, we can see the first method to connect our resources, IPsec tunnels. These are standards-based IPsec connections from branches and data centers. You can see we have a few tunnels created, and this one specifically for our data center. If we expand and view the details, we can see the reachable addresses behind the tunnel, as well as a status indicating that it's active. The second way to connect our infrastructure is through software-based application connectors. Application connectors are pieces of software that deploy close to your applications and build outbound tunnels to secure access. They enable connectivity without the overhead of managing network configuration, routing, or worrying about overlapping IPs. Application connectors are deployed in groups, so we're going to go ahead and deploy a new one for our apps. First, let's go ahead and enter a name for our application group, and then we're given a helpful slider to size our application connector. In this case, since we are deploying to AWS, we can see that based on our throughput requirement, we're given a recommended scale for the connector. This is helpful to ensure that the application connectors are sized properly. Once we create the group, we're brought back to the main screen where we can copy the provisioning key and get ready to use it in deployment. Jumping over to AWS, we can see that we've already started to launch the connector from a pre-built AMI. And all that's required now is that we pass the provisioning key along with the deployment in the corresponding field. You can see here in the corresponding field, we've entered our provisioning key, and we can review the settings of the image to make sure that it's sized properly for our requirement. Once we've verified, we can go ahead and deploy. Once this connector deploys, and we jump back into our dashboard, we can take a look and see that our connectors are starting to come online. There it is, 1, 2, 3. That's it. Now, at this stage, we can also map our private resources to the application connectors, but we're going to come back to that as we haven't defined the application just yet. Once we've connected our infrastructure, the next step is to provision our users and authentication. If we navigate now to the users and groups, we can see that we have all of our Active Directory users provisioned. Taking a closer look at the configuration, we can see that our users are coming from Active Directory infrastructure as well as Azure. This is where we're importing our user database. Below that, we have our definition of our authentication mechanism. This is currently using Cisco Security as our SAML provider. Now that authentication is set up, it's time to define our private resource and corresponding policy. Let's navigate once again to the Private Resources tab and take a look at our list of applications. Since we are adding a new application, let's go ahead and select the New App button. On the screen, we can give our application a name. In this case, it's going to be a VS Code server. Next, we can define how the resource is reachable. Now you can see this field is incredibly flexible. It can be as specific as a single FQDN and port or protocol, or as general as a wildcard domain or CIDR block. This gives you additional flexibility in how you can define your resources. In this example, our code server lives at a specific address and port, so we've entered it here. Next, we have the connectivity method. This is another unique feature in that when defining a private resource, we can define the method by which connectivity will be built. And here we can select from client-based ZTNA, client-less ZTNA, as well as VPN. This means we can select any combination of these three to allow for flexibility and access without compromising security. For our application, let's go ahead and permit access via all three methods. Now, it's important to note, all we've done is define the resource and how it can be accessed. We still have not defined any access policy. By design, all private access is denied by default. The last part of the application definition is to assign it to our resource group, so that we can more easily use it in policy. If we go ahead and look at our resource group, we're going to add this VS Code server into the previously defined resource group. Now let's shift over to that access policy. Like previously mentioned, by default, all private application access is denied. So even though we defined our application, we still now need to write a rule to permit access to it. Since this application is in our engineering access resource group, our engineers will have access based on the rule already created. However, we also want to enable access for our contractors. So let's create a new private access rule. We can give it a name and choose our source and destination. In this case, our source will be the contractors. And for our destination, this time, we will specify just the single code server app that we just defined. Once we press next, we can now choose posture methods for access. These are additional device and health checks before a connection is allowed, ensuring items like the OS and browser version are up to date. We can also validate and check against the presence of specific endpoint security software, the presence of a system password, as well as whether or not the disk is encrypted. All of these elements can be used to define a posture profile and assign that to this rule. Finally, we can select the IPS inspection policy. This will further secure the connection to ensure that traffic is not malicious through IPS signature detection using the latest in Snort signatures. With our rule complete, let's go ahead and press save. And since we are here in our unified policy, let's write some additional security controls for our internet-bound traffic. We can see that we already have blocked access to time wasters like gambling and social networking, but we want to do a little bit more control over some cloud applications. So let's create a new internet access rule. You can see here the rule is in the same unified policy, but now it has a few extra actions we can take. This includes things like warn, forcing users to pass an acceptable use policy, and isolate, which will isolate the browser session for the end user. For this rule, since we want to control some cloud applications, let's select the destination set being cloud storage applications and productivity tools. Once selected, we can dive deeper into the application level controls for each one of these selections. Here we can see we have the ability to permit or deny specific behaviors based on the application. Once we make our selections, we move on to security controls, and here we have further options including IPS inspection for the traffic flows, web inspection configuration, such as enabling or disabling TLS decryption, file inspection policies, as well as custom end user notifications. And finally, tenant controls. This allows us to enforce only approved corporate instances of productivity tools versus a user being able to log into public or personal accounts. And with that rule saved, let's go ahead and do the last piece, which is connect our private resource to the application connector we deployed earlier. If we jump back into the application connector screen, we can go ahead and select map our resource and choose our new VS Code server. And that's it. Let's go take a look at the user endpoint now. Here, our end user is going about their day, and as they go through their Jira, they see that they need to shift into a coding workspace. All they need to do is go ahead and select that bookmark for the application, and you can see the workspace is connected. They're seamlessly allowed access. Now they can do what they need to, add additional workspaces, and start getting to work. Since we're here, we can also validate that when the user tries to navigate to resources like Facebook and gambling, they're denied access. If we go ahead and open up a browser page and navigate to facebook.com, there it is. We can see that they're blocked. And the same goes for gambling. There it is. They're blocked. Now, with our end user up and running, we want to make sure their experience stays as optimal as possible. And if not, make the user aware of why so they can help themselves as well as admins if there is an issue that needs to be resolved. Let's take a look at this user now having slow response times to Box. We can see when they open up the browser, Box is taking some time to load. And then we're given a message indicating that the user is experiencing poor connectivity due to Wi-Fi. If we click that notification, we're presented with a message indicating that we have a poor experience to Box.com because our Wi-Fi signal is not the greatest. If we click on the details, we can see there's some recommended actions. We should either move closer or connect to a different Wi-Fi access point on a more favorable band. Let's go ahead and change the Wi-Fi settings on the host and connect to the 2.4 GHz band as recommended. Once that connects, you can see quickly our score changes, and we now have a notification that indicates our experience has improved. In the meantime, you notice in the background, the website started to load quickly. This capability helps our end users resolve issues quickly without needing to open a ticket and wait for somebody to help them, making both their jobs and the administrators much easier. And that's it. Thanks everyone for joining me for this first look at Cisco Secure Access.